Sure, I'll talk to you about the scientific revolution. Let's get into it. A big overarching thesis for really the first 5 units of study is that early modern Europeans are challenging traditionally held sources of power in all of the ways. In the scientific revolution, we see them challenge the power of like these Greek and Roman authorities, Galen, oh my gosh, in the Catholic Church. To contextualize, let's look back at the Renaissance, right? These Europeans now have access to Greek and Roman texts. There's this shift away from religion towards secular humanism. There's a focus on the individual and the natural world. All of those things together, plus the fact that these Greek and Roman texts and Europe hooking up to the rest of the world is going to inspire more diverse academic interests, paves the way for the scientific revolution. And it is important to recognize that because of trade, Europe is now getting advancements that existed in the rest of the world that did not exist in Europe during its Middle Ages or during its Dark Ages. With this new learning and with these new technologies, these Europeans are now going to start observing the world in very different ways, like Copernicus in Poland, who was like, maybe what the Catholic Church says about like the Earth being at the center of the solar system is not correct. Maybe the sun is at the center of the solar system, but also I'm a little bit too nervous about saying that out loud, so I'm just going to publish my findings right before I die. So then Galileo, using a telescope, was like, I'm actually going to prove Copernicus's findings. And what happened to Galileo? Well, he was brought before the Roman Inquisition, was deemed a heretic, was forced to recant, and then spent the rest of his life in house arrest. And Newton essentially synthesizes a lot of those beliefs with his idea of gravity. Kepler is also involved in dealing with the cosmos, but we don't need to talk about him necessarily. He just did like the elliptical orbits around planets. New scientists are not only looking at the heavens, they are also looking at the here and now and the body. Specifically, they're trying to rethink Galen's idea of the humoral theory of disease. Galen, this Roman physician, was like, the reason that you have problems, whatever they are, any kind of malady, is because the 4 liquids in your body, blood, black bile, yellow bile, and phlegm, were imbalanced. So you need to, in order to solve any of your problems, balance out those liquids, which is the easiest one to get rid of at any given time: blood, which led to the rise in bloodletting. And y'all, if you are sick and you are getting rid of the blood in your body, that's not very smart to do. To be fair, the Catholic Church had banned like dissecting human bodies for a long time, so I understand why this theory went unchecked for a while. But then William Harvey actually did start to dissect human beings and said, actually, there's like a circular system, maybe even a circulatory system that connects all of the blood that flows throughout our bodies. Shout out to Andreas Vesalius. He's one of my favorites because he did all of those like really awkward, weird corpse drawings because he spent a lot of time looking at the muscular and musculoskeletal system. We have the heavens, we have the body, and now we got to talk about the mind. We have Francis Bacon and Rene Descartes who come up with inductive and deductive reasoning processes respectively. The way that you can think about both of those things is that for a really long time, the Catholic Church said this is how it is. And now Francis Bacon and Rene Descartes are actually saying, what if we test some things based on some theories, or what if we like observe some things and like have some experiments based on that? Deductive and inductive reasoning it's essentially the scientific method, which is probably what you have used in your high school class already this year. Rather than relying on what someone has said to be true, you are going to use experimentation and oftentimes math to prove that thing to be true. Or to prove that thing to be false sometimes. To wrap all of this up, I'm going to talk about the Newtonian idea of the universe because this dominates scientific thought from the scientific revolution until Albert Einstein's theory of relativity. Newton says that the universe is infinite in size. It is existing infinitely in all directions, but he also recognizes its static nature, which means that it is neither expanding nor contracting in size. Lastly, he says that gravity is the governing force that unites all of this together. It is the single thing that is making sure all of these celestial bodies in the heavens are operating in a very knowable, predictable way. But then Einstein in the early 1900s proves that the universe is not knowable because in fact, space and time are not absolute, and then that throws everyone into a tizzy and into the age of anxiety.